Okay, so we did some linearizations yesterday. We went through number 10. So today, picking up, it says to approximate the root by using a linearization centered at the appropriate nearby number. Okay, so we're given in number 12 the cube root of 26. Okay, so what it wants us to do when it says something about the nearby number is to find a number that's close to the number underneath, okay, the radical, okay, and it wants us to approximate using that what the answer for this root would be. Okay, now notice this is a cube root, not a square root, so obviously a little bit different, but what number is close to 26 that is a perfect cube, if you will? Okay, so 3 times 3 times 3 is 27, right? So 27 is what we're going to want to use. So the closest is 27. So we're going to say x is equal to 27. Okay, meaning if we plug that in, okay, x being 27, y is going to be equal to 3. So we're going to say that there's a tangent line, or a tangent, okay, at the point, really I should say tangent, not line, because it's not really a line, at the point 27 and 3. Okay, so if we put 27 under the radical, then we take the cube root of that, it gives us 3, so that's the x and y value. So we're really treating this as f of x is equal to the cube root of x. Okay, let's see if I can focus this in a little bit and make it clearer. Okay, so I need to take the derivative of this function, okay, so I can think about this as x to the 1/3. So what would the derivative of x to the 1/3 be? Okay, so then I'm going to take and I'm going to plug in now 27 into the derivative. So 1/3 of 27 to the negative 2/3. Okay, so obviously this is a negative exponent, so it's moving it to the bottom. So 1/3 times 27 to the 2/3. Okay, I would say with something like this, you probably don't know offhand what the square of 27 is, okay? But you do know what the cube root of 27 is, okay? It's 3, and then take that and square the 3, okay? It just makes it easier to think about. It doesn't matter if you do the power first or like the root power first, if that makes sense. You can do it either way. I typically will do the root first, because it makes the numbers a lot simpler to deal with. So 27, take the cube root, that gives you 3. Okay, 3 being squared gives you 9, times the 3 that's out front, okay, is 27. So your answer is going to be 1/27. I have no idea. Hey Siri, what's 27 times 27?
27 times 27 is 729.
729.
Yes.
Okay, so 1/27th, okay? So what we're going to do now is we're going to do a linearization for the cube root of 26, okay? So we're going to do L of 26. So it's going to be 3 plus, okay, because that is f of a. Okay, so if we plug in that here, it gives us that. So that's where the 3 is coming from. Plus f prime of a, so 1 over 27, times I don't know where the thing is, but anyways, it's 26 minus 27. And I want to know what that's equal to. Because 27 was the closest to the...
In the f prime 27 above.
27 is the x value that we're looking at.
So how did we get 127?
Oh, so 27, the cube root of that is 3. And then square that, it's 9.
Oh, no. Okay.
And then times 3 is 27.
And that's what that fraction means? That's how you would undo that fraction?
Yes.
You can't take the square root of that cube root? That's fine.
No.
So the bottom is
Because this was a negative exponent, so I had to move it to the bottom.
yeah.
I could have treated this initially as I could have done, okay, well, I'm taking the cube root of 27 over here, and then I could have squared it, and then I said, oh, well, it's negative, and now move it to the bottom. I just like to go ahead and move it if possible, just to clear it out.
I just didn't know what that 2/3, or like when it has a fraction.
Mhm.
I forgot to roll for that.
Okay, so what does that equal to? Do we have that? Okay, so 2.96. So if you actually take the cube root of 26, so I don't know if y'all remember how to do that, but if you go to math and then you go down to option 4, that is a cube root, and if you put in the cube root of 26, what do you get? Oh. Okay, so that's just showing you that by doing it this way, we can approximate what they are.
Oh, stupid.
Yeah, just literally, just on your calculator, do this.
I took the cube root of 2.96. I did not get the same thing.
Can I go work on chemistry? Also, we didn't go to E4 today because yesterday we went to E4.
Yeah, yesterday we went to
And
the door
it
and we
was a
like opened the
problem,
door and she was
apparently.
like, "What do you need?" And we were like, "We're gonna take pictures for your book of the kids." And then she was like, "Well, it's not a good time."
So I just
anyways,
didn't
she's
even
like,
talk.
"I'll take pictures of them later." She
That's
was
fine.
really salty.
That's fine.
So. But the kids in E3, their picture was so cute. There's only 2 of them dressed up. The little girl was so cute.
You got it now, Melcher?
Yes.
Okay.
I took the cube root of the proper number.
That's good.
Yeah.
All right, so let's try another one. 14 is the square root of 80.
4.
4 squared is 80.
Oh. I was thinking cube roots and I was like,
I need a number close to this that's a perfect square. Okay, so the closest is 81. So we're saying that x is equal to 81. Okay, and we're treating this as the square root of x. Okay, so the... What?
how many more exams are we doing? Because I don't know if I have like this very small space, so like this is
This is the last one of this type, and then we're doing something different. Like, still in the section, but it's something different. And then we'll probably stop for today, and I'll let y'all work on the stuff that we did yesterday and today, and then tomorrow we'll finish the section is what I think is going to happen, because we wouldn't get through it all today. I just looked at it and was like, yeah, no, we're not going to finish it. Okay, so the tangent value, if x is 81, what is y?
2. I don't know how to find the y value.
What's the square root of 81?
9. Okay. Well, because last time it was 3, and I thought it was because of
Oh, yeah.
Sorry, just this.
That one was just an ironic situation.
So, well, that threw me for a loop. So that's why I started this scenario.
All good. I know, I was sitting there and I was like, do you really think the square root of 81 is 2? And then I was like, oh, okay, I see what you said. I see what you mean now.
I'm not that tough.
It's like, how'd you make it to this class? Just kidding.
Great question.
All right, so x to the 1/2. Okay, I want to take the square root of that. Or, well, hold on. Wow, I cannot talk today. How did I make it to this class? Okay, let's back up. I need to take the derivative of the function. So what is f prime of x?
Half. Yeah, half. Half x, then half.
Okay, yes. So then evaluate that at x is equal to 81. 1/2 times 81 to the negative 1/2. So I can move that to the bottom. Okay, and it's also going to be a square root because it's just 1/2. So then this is 1/2 root 81. Square root of 81, we've already said is 9. So 1/2 times 9 is 1/18. So then, to actually find the approximation, square root of 80 is equal to L of 80. So it's going to be the f of a, which is 9.
Is that too necessary?
Huh?
Oh, yeah, wait.
Oh, no, I don't know why I just wrote that. I was looking up here and just wrote it. No, it's not necessary.
Okay, that's good.
Like, it doesn't matter if you write it, I guess, technically, but no, you
The
don't.
whole square root of 80?
It's clearly not all the way with it today. It's fine. She's doing chemistry.
Okay, thank you.
I laugh because who else would she be looking for?
And who else would be doing chemistry in here?
Yeah, it's best.
It's fine. Okay. All right. So 9 plus f prime of a, which is 1/18, times the value 80 minus our a value, which is 81. So x minus a. So that would be, that's what I couldn't think of earlier. This is x minus a.
Oh, okay.
That's what I couldn't, earlier I couldn't figure out what the letters were, and I should have just scrolled back up and I would have realized. But anyways, that's all that is. So then I want to know what that's equal to. And then once you find that, actually take the square root of 80 and see what happens.
Is there anything else you need to do for your book?
Wow, school ends in like 2 months.
Right. Well, 3
Yes.
technically.
Oh my
But
gosh.
did you, I can't remember, did you actually end up doing the varsity volleyball page?
Mm-hmm.
Okay, then that is something you can do. Try to get an action shot of each person
Yeah.
if you can. And then you can put in the senior information for you and Amy for that, like on the volleyball page. So I'll put my quote in eventually.
Eventually. Usually takes a long time.
Did y'all get a answer for this? Did you get the same thing when you took the square root of 80?
Kind of.
What was it?
It was 8.94, but everything after that was different.
Okay. So that would tell us that we have 10 to the negative 3 would be where it's different, so we would have an error of less than 10 to the negative 2. So, anyways. Okay, so that was that for that type. So the next thing, so we had, the topic is linearization and differentials. So to this point, we've been doing linearization. Now we're going to look at differentials. I don't think I've written this information anywhere already. No, I did not. Okay, just making sure. Didn't do like all the notes at the beginning. Okay, so differentials. We say let y equal f of x be a differentiable function. The differential dx is an independent variable. And the differential dy is dy equal to f prime of x dx. So basically, all this is telling you is, you know how normally we write, like, well, I typically write it as y prime just for the sake of writing less, but how we had talked about, you can write it as dy dx. Okay, so basically that dx really goes on the right hand side, so it's dy is equal to blah 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 dx, telling that you took the derivative with respect to x. So essentially, that's the only thing that's different about what we've been doing. They're going to give us a value to plug in for dx, and they're going to give us an x value, and we're actually going to solve the differential, is basically all that's happening. It's not really anything super crazy. So it's really, the question's in two parts. Find dy, so take the derivative, and then evaluate dy for the given value of x and dx. So, okay. So number 16 is y is equal to 2x over 1 plus x squared. X is equal to negative 2. Dx is equal to 0.1. Yes. So we're going to plug those two things in for part B. So for part A, we want to find dy. Okay, yeah. So I'm going to write it like this, and then when we're ready to actually write dx, I'm going to erase it and just put dx on the other side, just so we don't forget about it. So what would the derivative of this be? Okay. So then now, the only thing that they want you to do differently is they actually want you to find dy. So what they want you to do is multiply by dx. So I'm going to get rid of that over here and throw the dx on this side. So if I told you to take the derivative, so if it was y is equal to x squared, what you would write on your paper is dy is equal to 2x dx. Okay. They're just asking you to eventually plug in a value anyways. But I just wanted you to see, normally we write it as dy dx, but the dx is now getting thrown to the other side, okay, by multiplying to get it over there. So that's just like a reference thing. So that's part A. Part B just says to plug in these values for x and dx and solve for dy. So B, it would be dy is equal to 2 times 1 plus, I'm going to go ahead and try to make this simple as possible. So negative 2 squared is 4. So 1 plus 4 minus 2 times negative 2 times 2 times negative 2 all over 1 plus negative 2 squared, or well, so that's 4. And all of that being squared times dx, which is 0.1.
Those are pointing the values. So for A, we don't simplify it?
No, just leave it.
Okay.
Because I guess theoretically the book may try to simplify it down or whatever, which is fine if you want to. I don't care. I'm okay with you just leaving it like this, because ultimately what I really care about is right here. I care about your final answer that you get here. So I always say, like, yes, you can combine stuff, but I just assume you leave it because I care about the final answer. So for these, these problems. So 2 times, that's 5, so that's 10. I've got 3 negatives, so that's going to be a minus. So 2 times 2 times 2 times 2 is 16. So 10 minus 16 over 5 squared, which is 25, times 0.1. And pretty much at this point, you need your calculator. Well, negative 6 over 25 times 0.1. Yeah, but that's equal to.
Negative 1,
Alright, so dy is negative 0.024. Alright, so we're going to look at another one of these. A little bit harder. So number 22. So 22, the problem is 2y is equal to x squared minus x times y. Yeah. Just leave that there until he comes back. It has a bump, like a thing on the back.
Urbana homecoming?
Yes. I have to take pictures.
Oh, okay.
Is Trevor coming?
Yeah.
Is he coming to chapel tomorrow?
I don't know. I didn't ask him.
Well, I was asking because
He's not escorting me. My dad's escorting me.
tomorrow.
Yeah.
Oh.
I mean, he could have, and like he would have done it, but like I don't know. I just figured that like
I was just curious.
just let my dad do it. I might have one. Yeah, kind of a hike. Considering he lives like way Gloucester. How far in Gloucester have you been? Like,
I mean, I've been all the way up to the courthouse.
so it's past that. You know where the hospital is?
Yeah.
It's like past the hospital.
Oh, okay. Well, yeah, I've been up that way because we
Do you know where? Okay,
went to Urbana.
Okay, do you remember seeing the farmer's market, the farmer's daughter on the right hand side of the road, like past the hospital?
I think so. I don't know. I followed Katie that way one day to do something, so I think so.
Okay, well it's that way.
But-
It's like that way.
That was a little bit of a hike.
So yeah.
He could just like stay over here for a couple hours and have lunch with you.
That's what I was gonna tell him. If he comes over here, I was gonna tell him, just stay in touch.
And then he could just hang for another hour and then you could go do something afterwards. After you're done.
That's true.
Okay. So, problem's a little different because we've obviously got y's on both sides. So, I need to move some stuff around to make that not the case because I don't want to, while I could do it implicitly, don't really want to. So, if I move the no. If I move the negative xy over to the left side, so if I add it over so that I have
It becomes the factor.
so if I do this, then I can take, rather than taking an x out, I can take a y out of both sides or both pieces.
And the same thought process is backwards.
Yeah. So then I'm left with 2 plus x is equal to x squared. So then I can truly get y by itself. So y is equal to x squared over 2 plus x. And then now I can take the derivative of it. So dy is equal to what?
Derivative of that. Alright, 2x times 2 plus x minus minus x minus x squared. All divided by 2 plus x, all that squared.
And then don't forget the dx.
Yeah, and then the dx.
Where are you going?
My car from my own. I need to come on them.
Have fun. Alright, so then now I can plug in the values. Okay, yes, you can simplify if you so desire, but I'm okay with you leaving it there. So then part B, dy is equal to 2 times 2 plus, or times 2 plus 2, which is 4, minus 2 squared is 4, all over, what is that, 4 squared, times my negative 0.05. So, what is that 16 minus 4 over 16 times negative 0.05. So 12 over 16 times negative 0.05. And I don't care at what point you plug this in your calculator. I'm just simplifying it down as much as possible. So 3 over 4 times negative 0.05. You could have plugged it in your calculator up here for all I care. I just Awesome. Not too bad, right?
I just drew a loaf of bread.
What?
I tried to make a circle and it looks like a loaf of bread.
Okay, that's what I thought you said. I thought you said something about a loaf of bread, and I was like, okay. Don't know how that's relevant, but all right. Okay, so the next one say to find the differential. So that literally just means take the derivative and write a dx at the end. All it means. So 24 d of e to the 5x plus x to the 5th. Okay, that's just telling you that you're taking the derivative of that. All that telling you, it's a different notation, but. So what would the derivative of this be?
The 5x. Wait.
Okay, yes. Well, so e to the 5x, we copy that down, we take the derivative of the 5x, so that's 5. So yes, it does end up being 5e to the 5x plus 5x to the 4th, and then we put parentheses around it, and we tack a dx on the end. And that's all you have to do.
What's that d in front of it? In the original equation.
What do you mean?
There's a d in front of
Oh,
it.
that's just telling you to take the derivative.
Okay.
Sorry, I thought you said e. That's why I was like, huh?
Oh, no.
Yeah, no. You just, all of that's telling you is take the derivative of that. Just a different notation for it.
And then it's e to the 5x. And how did I get that correct?
Okay, so it's you always, when you have e to whatever power, you always copy it down, and then you take, it's a chain rule, so then you take the derivative of the power.
Got it.
All right, one more of these, and then we'll stop for today, and we'll save the rest of it for tomorrow. There's not a ton left, but we wouldn't finish it, so I'd rather hold off. All right, so d of 8 to the x plus x to the 8. This one might require a little bit of thinking from derivatives of logs and exponentials. It's part of it.
Plus 8x is
And you're missing part of that derivative. But yes, that part's right. I'll give you a hint. It has to do with ln. Well, ln implies that there's an e, but
Oh. Okay, that's right.
it's ln of 8. So it's whatever the number is, you write ln of that number times whatever this piece is.
And that's only if it's raised to a coefficient, or, sorry, if it's raised to a power of a variable.
Yeah. The number's raised to a variable. Copy it down, take the ln of the number. If it was like a 2x up here, then obviously take the derivative of that too, chain rule wise. And then don't forget to put the parentheses around it and write the dx. Okay, so problem wise, what I would recommend you look at up to this point, 1, 5, 9, 11, 15, 17, 21, 23, and then I'll add a couple more to that tomorrow. But that's where I would start looking in terms of just what we've done so far. There's only about a page of examples left, about 4 more examples, but we'll do those tomorrow because they all are basically the same thing. And they're just a continuation of this stuff.